the pre-processing that we do to the data. So if we go to the monolingual data, you can see 2008, 2010, 2010, all this data is put into all.en. Uh, if you just see all.en content, you can basically sorry, you can basically see I mean some newspaper content on all.en. So on this all.en we run multiple Perl scripts for tokenization of the data. Those Perl scripts are coming from something called as the Moses decoder. The Moses decoder has like replace Unicode punctuation, normalize punctuation, remove non-authentic character, tokenizer, etc. once we uh, run Once we run these Perl scripts, what happens is the tokenized version is what we get in all.en.tok. So in here, as you can see, commas, apostrophes have been split out into individual words and periods as well, hyphens as well. So once we have that all.en.tok, what we do is we or some fragment of all.en.tok needs to be masked out using a special character. Once we do that, we move the data to the processed folder. So in the processed folder, uh, we can basically show you the following. Here k length is equal to 2. As you can see, some words have been masked with the special character at. Okay, and the rest my friends will be taking over from here.
All right. So speaking of the architecture itself, we are using a transformer model for training, which consists of an encoder and a decoder. Speaking of the encoder architecture, we've used the embedding dimensions of 512, although the paper uses 1024 due to our resource constraints. And we've used a 6-layered neural network with an activation layer called GELU, which stands for Gaussian Error Linear Unit. And along with that, we've used an Adam optimizer. The same architecture is also implemented for the decoder part. Now, Sudiksha will explain how the training process works.
So the basic, so how the model works is in the transformer model that we use, both the encoder and the decoder are jointly trained. And so for each sequence, we randomly mask continuous segments for every 64 tokens. And these masked segments are predicted at the decoder. So by only predicting the masked tokens, we are forcing the encoder to rely more on the unmasked tokens for representing the learnings. And by predicting the consecutive tokens in the decoder side, the decoder is able to build a better language model than just predicting the individual tokens. And some of the input tokens to the decoder are also masked. And these masked tokens extract more. By doing so, we extract more information from the encoder side. Over to Juran, who's going to explain about how the training and the output.
Okay, thank you. So let's have a look at how the training goes on. As you can see, the training process already started, and we are using, there was a data summaries about what sort of data we're using. As we can see, as time goes, the loss function in Math, English, and French are constantly decreasing, starting, and there was the times of how many words it is processing per second. And on the right side is the transform model that we use to based on. And in the meantime, all those informations are simultaneously transferred and recorded in a file called train.log. And those informations we can use for us to do later. So this is basically what trainings looks like. Let's terminate this because it takes a long time to train. So let's have a quick look at as the prediction model we have already had on. Okay, so here we use this command to run the translating Python files, and as you can see, we have 5 sentences of example sentences from the file of standing. And let's take an examples of the second sentence. And the right side is generated translated sentences that is coming out of our algorithms, and we examine this using a Google Translate to see how well we are doing as an example. So here is the translation of French. As you can see, as a comparison, the translated sentences is very much it's very much similar to the Google Translate result. So as we can see, we are having this code basically running, and we have a lot of to present, and the outcome is pleasing. So that concludes our presentations of the codes for now, and thank you all.